Everyone, welcome back to the channel. Today I'm going to solve one of the good problem, perfect square. So given an integer and return the least number of perfect square number that sums to n. A perfect square number is a integer that is the square of integer. In the another word, it is the product of some integer with itself. For example, 1, 4, 9 and 16 are the perfect square, while 3 and 11 are not. So if I will say the perfect square of 16 means if you take the square root of 16, you will get a 4, right? So you have to be, find the number of perfect square that sums is equal to n. Perfect. So we have given an input. So like for the 12, we need a 3 perfect square that sums equal to n. That is 12. Like 2 square, 2 square and 2 square. That is the 4, 4 and 4. That is equal to 16. Sorry, that is equal to 12. Right? N is 13 and output is 2. So how many perfect square that needed that make the sum is equal to n? So that is 2k square and 3k square. That is 9 plus 4 is equal to 13. Perfect. And we have given the constraint. So let's understand the solution. So this is the recursive solution which is not optimized and it's also complexity is too much high, right? Exponential complexity. So it will not. So it's not good way to solve this problem. But again, we have given like base cases that if n is zero, then we have to return a zero. Here I have count minimum count that needed to make the sum is equal to n. Means we have to count the minimum perfect square that needed to make the sum equal to n. Given a slide the minimum count equal to the integer dot max value with the maximum value of integer. We have used, I have used here loop iterating from the 1 to n. Here is the method name is given, means we are doing the recursion here, right? Every time we reducing the perfect square from the n, we count to 1, right? So it will give you the number of perfect square needed to make the sum equal to n. Like every time you are counting from 0 to, suppose n is equal to 12, then you will count a perfect square from 0 to 12. Every time you need to count that how much perfect square needed for each number, right? For the 4, how much perfect square needed to make the sum equal to n. For the 12, that is here given the 3 perfect square needed to make the sum equal to 12. That is the 2 square, 2 square and 2 square is equal to 12. That is the 4, 4 and 4. So every time we reduce the perfect square here, right, we increment the 1, and we need to we return the minimum count, right? So for that I am taking here the minimum value. I return the minimum count. But this is not the optimized solution. Like if I will going to if I will submit the solution, it giving TLE, right? So we will not move through this. We will try to move through the dynamic programming plus and with memorization, because that is more optimized and so instead of any zero, if any instead of this base cases, we will take this slide the dp is equal to 0, because if you take the perfect square of 0 you will get the 0, right? So let me uncomment all. This is dp line programming, the memorization. So in this what benefit I will get? So I don't need to recount every time the solution that we have already computed, right? So it will help me to uh, you know to reduce my time complexity and it is more optimized, right? So this is a solution that I'm going to be returning, and it will accept, I think. Perfect. So I even slice here dp0 and for loop. Initially I have kept maximum value of integer. I even slice. Okay, perfect. So let's run it and see that if it is correctly running or not. Yeah, it's running. Let's submit it and it's accepting. So it's a good approach. And so the earlier it was a recursion, now it's a dynamic programming approach. DP with memorizations. I do the for loop the data heading from 1 to n. Just like j is equal to 1, here it is a perfect square, and every time you need to be count that perfect square should be less than equal to n. You don't need to make the perfect square should greater than n, otherwise you will move out of the box, because you have to find some up to the n only. Every time I will get the perfect square, I will reduce from I and count it to 1, because I have to find the perfect square needed that make the sum equal to n, right? And so and return here. So this is solution. Hope you like the video. Subscribe the channel.